When we're building software, we're usually trying to solve some kind of real world problem. But that means we have to, describe that world to a computer. So, how do we do that? How do we teach a computer about something from the real world, like a phone?
Seriously, think about that for a second. How would you actually do it? You can't just show it a picture and hope for the best. You need a system, a way to define what a phone is and what it does, not just for your phone, but for any phone that could ever exist. And that right there is the exact problem that classes and objects were made to solve. Okay, let's really get into this.
And the solution? It's actually pretty brilliant. Instead of trying to describe your specific phone, you create a master plan, a blueprint. This blueprint doesn't represent any single phone. No, it contains all the rules and characteristics for what makes a phone a phone. And in the world of programming, this master blueprint has a special name. Yeah, we call it a class. That's the word you gotta remember. Think of the class as the architectural drawing, the master plan, the recipe. The key thing here is it's just the definition of something, not the actual thing itself. Okay, so let's break down the official definition. A class is basically a blueprint that defines two key things. First, you've got attributes. That's just a fancy word for the stuff an object has, its properties. And second, you have methods. Those are the actions, the things an object can do.
So if we take our phone blueprint, right? The attributes, the things it has, that'd be stuff like its brand name, how much RAM it has, or that unique IMEI number. And then the methods, the things it can do, well, that's going to be actions like calling or texting. The class basically says, hey, any phone we build from this plan has to have these parts and be able to do these things.
Now, this is a really crucial point. Just because you've drawn up the blueprint doesn't mean you've built a phone, right? It doesn't take up any physical space, and in the computer's world, it doesn't take up any memory. It's just an idea, a plan sitting there, waiting. So, if the class is the plan, what happens when we actually, build something? Well, that's where the object comes in. The object is the real deal. It's the tangible thing you build from the blueprint. It's the finished product. Officially, an object is a single, concrete instance of a class. Now, instance might sound a little academic, but it's just a way of saying it's one specific example created from the blueprint. This object now has its own actual data, like the brand name is Samsung, and it can do all the things that the blueprint said it could. And this makes it super clear, right? Your Samsung Galaxy is one object. My iPhone is a completely different object. They're separate, individual things, but they were both built using the very same mobile phone blueprint. And here's the big difference from the class. When an object gets created, it absolutely takes up space. It becomes a real thing inside the computer's memory. It actually exists. So a blueprint is just an idea. An object is a reality. Okay, let's pull all this together. This table really lays it all out. The class, on the left, that's your abstract blueprint. It defines the rules, uses zero memory, it's just a concept. But the object, over on the right, that's your concrete, actual phone. It follows the rules from the blueprint, it takes up memory, and it's a real thing you can use. It's the idea versus the reality. Simple as that. All right, so how do we actually tell the computer to build one of these objects using our class blueprint? Well, it's actually just a few simple steps in the code. You can think of it like sending instructions down to the factory floor. So here's what it looks like. Step 1, we declare a variable. Think of this like yelling down to the factory, hey, clear a space on the assembly line. We're going to put something called iPhone here. But notice, nothing's been built yet. It's just an empty spot. Step 2 is where the magic happens. We use that special new keyword. This is us telling the computer, all right, grab that mobile phone blueprint and build me a brand new object right now. And then finally, in step 3, our object actually exists. So now we can use it. We can tell our shiny new iPhone object to do something, like get its name. I really want to zoom in on that new keyword. That is the magic word. It's the command that makes everything happen. When the computer sees new, it finds the mobile phone blueprint, sets aside some memory for a new object, and brings it to life. It's basically the start manufacturing button. And this is where the real power kicks in. Just like in a real factory, you don't need a new blueprint for every single phone you make. You use that same class blueprint over and over and over again to create thousands, even millions of unique phone objects. Each one is its own separate thing, but they all follow the exact same master plan. Okay, so why? Why do we go through all this trouble with blueprints and objects? Why does this matter so much in programming today? Well, it turns out this structure gives programmers some absolutely massive advantages. First up, and this one's huge, reusability. Like we just said, you can use the same class, the same chunk of code, over and over again to create as many objects as you want. This saves an unbelievable amount of time and effort. You write the blueprint once, you use it forever. Second is organization. A class neatly packages up all the related data and actions into one tidy, self-contained unit. The fancy term for this is encapsulation, but honestly, you can just think of it as keeping your code from becoming a giant tangled mess. It's all about keeping things neat.
And third, security. The blueprint lets you protect important information. For instance, a phone's unique IMEI number. That's pretty sensitive. Inside a class, you can actually hide this data, which stops other parts of the program from accidentally messing with it or deleting it. This is absolutely crucial for building software that's safe and reliable. So when you put it all together, this whole idea of bundling data and actions into these blueprints, well, that's the foundation of a really powerful style of programming called object-oriented programming, or OOP. It's an entire approach that helps programmers wrangle complexity and build rock-solid, reusable code. And classes and objects, they are the absolute bedrock of it all. So there you have it. We started with a simple question. How do you describe a phone to a computer? And we ended up with one of the most important concepts in modern software. Just remember, the class is the blueprint, the object is the real thing you build from it. It's an incredibly powerful way to model the real world in code, which, of course, leaves just one final question for you. Now that you understand the blueprint, what are you going to build?